All right, so we are live again. So, what we are going to be doing today for the people that are just tuning in right now is we're going to be discussing some of the new AWF compliance things that are coming out to the market. And we're going to be talking about that with a representative from SPORLAN. So, we have Jerry Wallach here from SPORLAN. And of course, I got Brett Wetzel from Its Refrigeration Podcast right next to me. And first off, Brett, you a little bit different than yesterday. So, how's the show?
Wonderful.
Yeah.
I'm exhausted. I'm getting to the point where I'm just, like I said, information overload and basically just going through and seeing all the stuff that I can.
Yeah. I still, I've walked around the show a little bit, and it's amazing how big it is. I know it's a little bit smaller than last year, but it's still really cool. The attendance, I'm actually pretty impressed with the attendance because I kind of thought it was going to be a little bit lower. I'm still guessing. I haven't heard any official numbers, but I'm guessing maybe we're going to see total attendance numbers of about 20,000 people. But I'd be kind of curious. So, what about you, Jerry? What do you think of the show so far?
I think it's been good. I've been surprised. I thought it was going to be way less.
Yeah.
We've had good booth traffic.
Yeah.
I think we've had a lot of people watching you guys. So
Oh,
thanks for doing
cool.
this.
Yeah, no problem. So we want to talk a little bit. We've been really harping on this, and we want to make people more aware about the new AWF compliance requirements that are coming out. First and foremost, I want to make everybody know, because I've seen the emails. I've had people ask me, why in the heck is insert name of manufacturer? Are they installing these head pressure control valves with the cut-in or the bypass pressure so low? But they're more or less blaming the manufacturers, and I guess for most they would think that that's how you have to do it because the manufacturer is the one that has their name on the equipment. But really, this is a federal mandate to try to reduce the energy consumption on the light commercial sector, basically. Now, the supermarket side, obviously, you guys have, already pretty energy efficient systems, or maximized to the most that they can get, because they're more hyper concerned about the costs.
Well, we're more precise with controlling saturated condensing temperature as well as suction pressure. So the problems that we're seeing with the AWEF stuff, yes, we are still seeing that. You'll see it in a lot of single systems. That are installed that maybe they don't have enough capacity, or they're installing in a different part of the store with the rack's not available. They'd have to run an excessive amount of piping.
Yeah.
So that's a lot of times why like these single systems end up getting installed. But we are still having a lot of the problems with the AWEF stuff. Not that it's a design thing that has to be looked at when working on it.
So when it comes to the AWEF stuff, it is a federal mandate. Each manufacturer is, maybe you can help me with this. Can you correct me if I'm wrong? Is it not just they're giving them a guideline of energy efficiency? They're not so much saying that they have to do this or this. They just have to meet a certain goal, correct?
Correct. Yeah. Below 3,000 square feet, I believe it is.
Yeah, 3,000
you
square
have
feet.
to meet the AWF guideline for energy efficiency. And essentially, it's kind of like SEER, but for walk-in coolers.
Yeah.
So everybody's known about SEER for a long time. It's really a similar concept. You're just looking at total energy for the annual. So you're taking into account low ambient conditions and high ambient conditions. So one of the easiest ways to improve efficiency is to let that head pressure drop, because that compressor becomes way more efficient.
Yeah. And I've seen a couple different methods. What we're seeing is added subcooling circuits. We kind of talked about this a little bit yesterday, but I deal with single component systems, right? Single compressor systems, no variable capacity. So we'll see single systems. They'll put a head pressure control valve on there. They'll float the head pressure down to about 110 psi bypass pressure for freezers, about 150 psi bypass pressure for coolers. But then on top of that, like I said, they'll add that extra subcooling circuit where it'll leave the receiver, run back through the condenser one more time, just to give you, the added guarantee that you have a solid column of liquid going to the expansion valve. Then what they will do oftentimes is add 2-speed evaporator fan motors, which is a whole nother issue, but we can get into that later. But I really want to talk about the head pressure control valves here. So the problems that I've been seeing is issues within, my mild climate. Because here in Southern California, or where I'm from, Southern California, we have extreme heat in the summer, but very mild winters. I mean, on average, 50-degree winters. And we start to see issues with the head pressure not even getting low enough to bypass the head pressure control valve. And then when it does, we do start to see issues. And I kind of wanted to get your take on, what do you think as contractors and as technicians, how can we better ourselves to kind of combat these issues? You know, and what is happening though is a lot of people are going and buying, let's say they have a compressor replacement, and they'll go buy a condensing unit from the supply house. And I will say, to be fair, the supply houses are not, whether they're not educated on it and or they just don't tell the contractor, they are now selling them an AWF compliant condensing unit. And they may not be planning on doing anything to the evaporator, changing the expansion valve or anything. And they may think, like in the past, they can just throw a condensing unit on it and call it a day.
Right.
But then come this winter time, the mild weather, they start to see issues. And on top of that, Brett and I have had pretty good discussions about this, but most of the equipment I work on is massively oversized.
Right.
And so what I start to see is crazy high evaporator TDs, and then you start to run into issues, you know? What like you've had a lot of experience with these high TDs. What do you start to see on the evaporators when you run into these issues?
So it'll be weird because like you'll have a full column of liquid. You'll check the filter dryer, make sure there's no temperature or pressure drop across it. You'll check your actual subcooling. Typically off of like a single condensing unit, you might get upwards, maybe if you're lucky, about 4 to 5 degrees of subcooling. If you do have an extra subcooling pass, if you talk to a manufacturer like Hvacr, they'll typically tell you that you'll get additional about 10 degrees of full subcooling. And I guess, that's really, maybe what they're trying to accomplish by putting that extra loop in there, because we end up running that high TD. Basically, the evaporator basically doubles in size. If anyone isn't aware of this, typically evaporators are sized for an 8 to 10 degree TD. Now, what that means is if we're trying to maintain 30 degrees, our saturated suction will be 20 degrees. That gives us our 10 degree TD. Now, the problem is most evaporators are sized off of that. So if it's a 1 ton coil at a 10 degree TD, it's still a 1 ton coil and requires a 1 ton expansion valve. But because now we're doing the floating head, which is basically lowering our saturated condensing temperature, which now is increasing our capacity of our compressor, which now is lowering our suction pressure, which now raises a higher TD. And anytime that you basically raise it from 10 to 20, that coil is no longer a 1 ton coil. Now it's a 2 ton coil. Right. So you have to make sure you actually have that capacity of that expansion valve to accommodate that, or potentially have a little bit of extra subcooling. So what are they actually doing? Because I mean, you're not guaranteed that you're going to get that subcooling, and a lot of people don't understand. Technicians don't understand that single systems need to be charged to about anywhere from 60 to almost 80% to compensate for when the headmaster actually starts to work. It's going to pack that refrigerant in there, but also give you some additional subcooling, which might actually offset some of the AWF high TD. In my professional opinion, I'd be all day long. I'd want suction capacity control. But
right,
your thoughts?
Yeah, we when we looked at this situation with AWF, we knew AWF was coming. We wanted to make sure that we have to train the industry, because you can't size an expansion valve for an AWF unit like you had in the past. Because in the past we had minimum head pressures of typically 180 or 210, depending on the refrigerant, and that guarantees you have a certain amount of pressure drop across the expansion valve. We would commonly size expansion valves, between 90 and 100%. There's a little reserve capacity. We rate them at 85% stroke, so there's you can basically go to about 107%. But if you do that today on an AWF unit and you go down to 100-pound condensing, you have way less pressure drop across that expansion valve, and the capacity on that unit is way higher. So it's just, you've got such a the pressure drop basically through the compressor across the compressor is way lower. It's way more efficient. It's, like you said, it's going to double the capacity.
Yeah.
So one thing I want to add, I'm sorry, like if anyone has ever looked at the Bulletin 1010, which is the expansion valve document, I'm real lame, that's why I know it. But basically, if you look at that, if you look at most of the expansion valves, they're typically sized for 150-pound pressure drop and 100-degree liquid. So if you take any expansion valve that says 1 ton valve, that is only a 1 ton valve at a 150-pound pressure drop, typically in 100-degree liquid. So anytime you start changing any of those factors, where if you have a higher delta P across that valve, that's the difference between the suction and the liquid, it's going to increase the capacity of that valve. And if you lower the liquid temperature by adding additional subcooling, you also make that valve bigger.
Right. And we tried to work with all the manufacturers, Hvacr, Keep Right, HTPG, and Copeland. And we basically said, all right, what's the worst case scenario? Because we want to kind of make it easier for the technicians and the wholesalers out there.
Right.
So when we put together this Bulletin 500-10-AWF, and basically we take into consideration the worst case scenario with head pressure, pressure drop through the distributor, and we size the valve so that it can work at all the conditions. So we've really basically give you It's kind of a really easy thing. We should have been doing this for a long time to basically kind of simplify it.
Yeah.
But it's really nice. You basically look at your, get your refrigerant. You got to know your BTUs of your system at design condition, and then you basically look for it on with the evap temp, like plus 25, whatever. Come down, see 5,500 BTUs. You go over and say, all right, it's a AA port.
So just to clarify, if you guys Google search SPORLAN AWEF, it will come up, but you are also looking for Tech Bulletin 500-10-AWEF, and that will help you to size the expansion valves correctly. Now, keep in mind, though, we need to really pay attention to our equipment sizing. We cannot have a fudge factor in there anymore. We need to make sure that we are properly sizing and matching our equipment to meet the AWF requirements and or to make this equipment work properly. So it's not just as simple as changing out a condensing unit anymore. We really need to dig deeper, make sure that this system is set up, because it's very common. We have a lot of oversized equipment out there, and while it wasn't working properly, it got by. But you are gonna run into issues for sure. I also want to stress the fact that there's nothing wrong with this, but there's a lot of people that don't understand that when you have a head pressure control valve in a system, that means that that system is now a critically charged system, okay? Unfortunately, there's a lot of misinformation out there. When we use the term winter charge, people seem to think that winter charge means you put extra gas in the winter and you take it out in the summer. If a system is designed properly, and that's the key, if it's designed properly, what goes into the design is a load calculation, an evaluation of the equipment, making sure that your equipment is rated for outdoors. In the past, we used to take indoor equipment, throw it in a doghouse, and throw it on the roof. That would get you by, but oftentimes the receivers are not sized appropriately for a 50-foot, 75-foot line set or in excess of that. So we really need to pay attention to our component selection, our equipment selection. There's a lot less fudge factor built into things. We really need to control the size of our equipment. And if we try to throw, just a new condensing unit on there and it's marginally sized or it's oversized, you are going to be running into issues. Now, I'm going to share a story. I haven't made a video about this yet, but I was recently working, and I talked to Brett about this, but I was recently working on a Heatcraft intelligence system. And long story short, we had a time delay relay installed up on the condensing unit that shouldn't have been there, but the equipment operated fine for most of the time. But what happened was, because the equipment is slightly oversized, it's out in the Palm Springs area where we had 120-degree ambient, and it's now 50 degrees right now. We have a rather large condensing unit. So with the lower ambient temperatures, we also had some issues with the pressure control setting. Our system was doing some funny things, and it would actually start up, pump down, and shut off, or it seemed like it was pumping down, but it was actually because it had an EEV and we were running into issues because of the time delay relay. What happened was the Heatcraft intelligence systems and the beacon systems and all these, the electronic expansion valve learns from itself. And so the next cycle, they'll base it off of some run factors that happened in the previous cycle. So in our situation, we had an incorrect setting on the pressure control. It was a perfect storm. We had a time delay relay in there that shouldn't have been in there. And our system would run such a low suction pressure because our compressor was massively oversized, it would actually shut the compressor off on low pressure. Then that time delay relay would kick in. It would have a 3-minute time delay, and it just caught in a vicious loop of learning from itself, and it just created an epic disaster, all because of a time delay relay and really a pressure control that kind of drifted that needed to be adjusted. But it had to do with this oversized equipment. And sometimes in the field, we have to make certain things work. Manufacturers ship out equipment and they don't necessarily pay attention to certain things, or people. When I say manufacturers, I deal with customers that order a lot of their own equipment. So they have manufacturers contacts that say, this should be fine, this will work. Whether or not they're actually associated with Heatcraft, probably not. They're more or less a distributor that's selling direct to a customer. And you get a lot of fudge factor. So we need to get away from the idea of this should be okay. Should be okay is never a term that we want to use when we're sizing equipment. It's this will be okay. This will operate within this tolerance, and it'll be fine. But we can't be having this winging it stuff anymore, because, man, are we in for it if we keep installing equipment incorrectly and not understanding. Now, on your guys' level, you guys have capacity control. On my equipment, we don't have capacity control. Our compressor is now a 5-horsepower compressor because it's wintertime. It was a 2.5 horsepower in the summer, and this happens. So I am used to seeing really high TDs. And when I say this to Brett, he's like, dude, you get, and I get it. It's a compressor killer, but that's a very common thing for me is 20-degree evaporator TD. That's really common. We have a massive defrost strategy on most of our equipment because on top of that, customers are leaving doors open. They're not using the equipment right. So, and then we're running a massive TD, a really cold coil, and we have a lot of freeze up issues. But I think the biggest takeaway from all of this is we need to understand how this equipment operates more. We need to understand the process. Me personally, I'm not a big fan of people doing equipment sizing and different things for me. Yeah, I know I can give the information to the supply house guy, but I love to get my fingers on it. I'm always curious. I used to do that. You know, what size equipment do I need? We give them some specs and they'd give it to me. And I was always curious, like, how did we get to that process? So I start researching it, doing it myself. And I'll even admit for a long time, I was oversizing equipment too, because, oh man, that doesn't seem big enough. I'm just going to go a little bit bigger, but we can't be doing that anymore.
Well, it comes down to education. It's the manufacturers working with.
So you're saying I don't know what I'm doing?
No.
Yes, yes, that's what he just said.
No, I didn't.
I heard it.
That's what I heard.
No, but no, really what it comes down to is making sure the manufacturers are educating the people that are actually sizing it. So, excuse me, like supply houses, where a lot of times for these smaller commercial applications, they're the ones that's like, oh yeah, that'll work for that. Well, like you said, years ago, yeah, fine. But now, because of all the new standards, we run the risk of it not working right, and then it always falls back on the manufacturer. Oh, it's a hunk of junk. It doesn't work right. Well, it would if it would have been sized for that particular aspect, right?
I also do want to bring to the fact when we talked about refrigeration systems when they have head pressure control valves being critically charged. That's so important. SPORLAN actually has a tech document, bulletin 90-30-1, that'll help you on a tube and fin condenser. Let me reiterate, a tube and fin. So that is copper
right.
tube and aluminum fins, okay, that will not work on microchannel condensers. It does give you a process to rather easily calculating the proper flooded charge for the system in whatever conditions you set. So you set the minimum outside ambient conditions within the mathematical calculation that they're going to give you. So it's literally just a couple measurements, multiplying a few tube lengths, finding out the equivalent length of all the copper in the system, calculating the what am I looking for? Internal volume of the pipe. There's a name for that. The density factor of the refrigerant, and throwing that in there. And then you come up with a calculation of the proper flooded charge. But let's reiterate this. A winter charge is a technical term that we use. I don't know technical, but it's a term that we use for the longest time. It does not mean you add refrigerant in the winter and you remove it in the summer. Okay? It doesn't mean that. Okay.
Are you sure?
I'm sure.
Okay.
If the system is properly sized. I have to say that with a caveat because, if you have an indoor condensing unit mounted 50 foot away from the evaporator and the roof, okay, I understand. It's still not designed right, but I understand why someone might have to add refrigerant or remove refrigerant. But if a properly installed system, at least with what I'm dealing with in the supermarket side, are your receivers always sized to pump the entire refrigerant charge into them, or are they so big that you can't do that?
In the summertime, no.
Okay.
In the wintertime, we can pack a lot of refrigerant. If it's a tube and fin, we can pack a lot of refrigerant in the actual condenser. So if we don't have that capacity to, because you got to remember, the lower you get that liquid temperature, the more dense that liquid actually is. It's almost like it's comparable to a higher octane refrigerant if you really think about it, right? So running refrigerant at 50 degrees is like running clots in your Civic. You know what I mean? Where basically it's going to add a lot more capacity. So same principle where, if it's a lot colder out, you're going to be able to pack more of that refrigerant. Or same thing when you're recovering refrigerant from a single system. I see a lot of guys using a coiled up piece
Subcooler,
of piece of tubing that they throw in an ice bucket, and they can actually fit more refrigerant. And that's because the density changes because it gets more dense, and also the volume, because we deal with that also in commercial with supermarket stuff, where basically I've dealt with a store where basically the liquid receiver level is 20%, subcooler's not working, then all of a sudden I get the subcooler working. Now I have 0%. Well, basically now, because we're subcooling it all the way down to 50 degrees, now that liquid is a lot more dense, takes up less space. So now it takes more refrigerant that would have been the receiver to go out into the system to take up to match that where we took it away because we changed the density.
So on our stuff, we're always trying to make sure that our receivers are sized appropriately so they can pump most of the refrigerant charge into them. And I can tell you this right now, if you have a receiver on a condensing unit and you cannot pump down the entire refrigerant charge, you cannot add winter charge to that system, you're going to have a problem.
So I have a question for you. So like my for single systems, my rule of thumb is anywhere from 60 to 80%, as long as it's above 75 degrees, because we don't want the headmaster or the LAC to basically start, packing refrigerant in while we're trying to figure out what 80% is, because then summertime would be way overcharged. What are your thoughts on that?
Well, you definitely have to take into account what head pressure control valve you have, whether it's 180 pound, 210, because a lot of people don't realize that once it gets below 70 degrees, if you have a 180 pound valve, you're starting to back up refrigerant in the condenser.
Absolutely.
You definitely have to take that in consideration and use the charts that you talked about with 90-30. And basically, you just got to calculate the charge and weigh it in, and then know how much is already in there. Let's say you're using the chart, you're like, oh, I got 20% in there already. Well, then you got to add the rest of the 80%.
So what I'll do is, once I've calculated the proper flooded charge, then I will pump down the receiver, find the liquid level, and mark it for the next guy. So on our side, we are not running into receivers that we can see liquid levels or anything like that. We have pretty dumb systems.
You can kind of do a torch.
Well, yeah,
I don't ever use a torch because we use a heat producing device.
Okay.
We're not gonna say what the device is because but no, yes, you can use a heat producing device.
Thermal imaging camera.
Yeah,
Gotcha.
you can use a heat producing device and a thermal imaging camera, and yes, you can see liquid level. And I will say that, for the longest time, most of my career, use the back of your hand, find the liquid level. But since I've started using a thermal imaging camera, that actual liquid level that I feel with my finger is a lot different than the liquid level you see with the thermal imaging camera. So you can get a lot more accurate with it.
The concept is, what we're talking about is basically, if you're heating up that refrigerant, if you're going up and down up the receiver, basically the liquid refrigerant is going to absorb the heat. So it's actually not going to get hot. And anywhere where you have the vapor is going to get hot because that liquid isn't there to actually absorb the heat. So there's no state change. So it gets hotter and takes that sensible heat. And that's why what we're talking about actually works.
I will say too that let's make sure that we address the fact that at any given time, you have to make sure that a fully pumped down receiver's level does not exceed the 80% number. And if you do exceed the 80% number, you run the risk of having a catastrophic failure of that receiver, some sort of an explosion. Now, yes, there's soft plugs and different pressure relief devices in there, but you don't want to test those limits. You want to make sure that you don't overfill your equipment for safety reasons.
And that's why we're highly recommended always to actually put the solenoid or electronic expansion valve as close to humanly possible to that evaporator. So, because systems aren't, a lot of systems weren't made to have a solenoid all the way back at the condensing unit and pump 100-foot down a line down or a 50-foot line down. Yeah. So if you do have a system where it is sized properly and you are having head pressure issues when it pumps down, look at where the actual solenoid is. Recommended that it's as close to humanly possible to the evaporator, or where the T is, to basically feed a multiplex type system.
And in some of the most extreme conditions where you just can't get it to pump down right or anything, what you can do, like Brett's saying, is you can move the solenoid valve. If it is up on the roof, you can. That's a last ditch effort. You can move it down to the equipment to try to get that extra 50 feet of
sprinkler
liquid line or
sprinkler.
Whatever.
We just put a sprinkler on it, right?
There you go. Put a sprinkler. That's like get me through the summer when I can't find the condenser fan motor day. So
I'm just kidding. Please don't do that.
So let's address the fact with microchannel condensers. So we have microchannel condensers out there, and we do have to understand, we already said it, I'll reiterate, that SPORLAN's 90-30-1 method does not work on microchannel condensers. That creates a whole nother issue. For that, you're going to need to reach out to the manufacturer of said equipment to find the proper liquid levels. Ironically, I actually, with certain manufacturers, they just tell me to put the maximum amount of refrigerant in that system, which can be a problem, right? So with what I'm dealing with light commercial systems, nothing bigger than 3-4 tons. So yeah, maximum charge 25 pounds or something like that. But if you actually calculate a flooded charge for some of that equipment, if you put the max charge in there at 25 pounds, you might find out that the calculated flooded charge with all the refrigerant in there might only be 15 pounds. So theoretically, you are selling the customer a little bit of extra refrigerant. But if the manufacturer doesn't have a better way to charge that system, i.e. the microchannel, because it's so minute, sometimes I've had them tell me, just fill the system up to the max charge. And so you have to find the published data for that refrigerant. It's not going to be, just because it's 24 pounds of 404 does not mean it's going to be 24 pounds of 448A or R22 or insert, because you have to pay attention to the density factor of the refrigerant and find out that proper charge.
And with the AWF units, because they have lower head pressure settings, you're not going to need as much refrigerant as you did with the 180 pound setting or 210.
Right.
So you're not going to flood all the condenser. You don't need to. They're going to let it float down.
Yeah, and in most situations, like I said, in most of my times, I'm never going to hit that number out in SoCal because we're hitting 60 degrees outside, and it's not quite there. So, you know, we're not necessarily going to hit that. And what's interesting too is when I do see, when you actually find out from the manufacturer how much extra refrigerant you have to add on those microchannel condensers, it's like scary how low that number is, you know, because we're so used to tube and fin, and we're like, yeah, we need to add an extra 8 pounds to that system. And you find out it's half a pound, and you're like, for a 3-horse, you know, I mean, oh my gosh, but that's the efficiency of a microchannel condenser. They can do so much more in there.
So the slabs on some of the supermarket, when I say slab, basically, you know, I'm talking about a microchannel condenser. Typically on the Hussmann units, I mean, they're fairly big. They're like 4 feet by 4 feet, and that holds, I think, like 2 pounds or 5 pounds of refrigerant. Where typically, you know, in the wintertime, you could probably jam 30, 40 pounds in there. So, you know, that's why a lot of companies are going with the microchannel, because it's a big sell to have a reduced refrigerant charge, because then they don't get charged as much with the government. You know, they get a tax break once again, just like the you know, the AWF stuff, you know.
Right. Yeah. So I think the takeaway is that us as contractors, us as technicians, need to do a little more research, make sure that we pay attention to what we're installing, make sure we understand how the manufacturers want it installed, and make sure that we know what's going on with our systems. With today's equipment, it's so much more efficient. There's circuit boards and everything. There's sensors everywhere. Proper efficiency, it will not operate if it's not charged right. It will not operate right. You have sensors and everything that are going to go nuts if it's not installed right. We have to follow installation instructions, and we have to dig deeper, other than just having a supply house tell us that, oh yeah, this should be fine. You know, we need to look into there. Really, another thing that we really didn't cover, especially in the retrofit market, is liquid line sizing too. That's a really important thing, especially when we're changing over to these new refrigerants. You know, going from an R404A system, thinking that we're just going to change the condensing unit, because there is some manufacturers out there that say, oh yeah, you can use 448A in a 404 evaporator, you just got to make some adjustments here. But what you don't know is now your liquid line is massively oversized, because we don't need a 1/2-inch liquid line going to that evaporator anymore. Sometimes we might even need a 1/4-inch liquid line. You would be surprised to read installation information, and you start really digging into refrigerant line size, and you're like, wow, that's really small.
One of the other things that gets overlooked a lot is the distributor nozzle.
Yes.
Because what ends up happening, like, you can have an old unit that was R22 and convert it to 407A. And because of the pressures and the glided refrigerant, a lot of times you have excessive frosting that ends up happening on the distributor tubes, and you have less, you know, actual flashing going on in the evaporator. So, I mean, I know in commercial, a lot of times it's wham, bam, thank you, ma'am, get it done, get it in. But like with some of these more delicate single systems where, you know, the ambient really affects, you know, how the pressures react. Be aware, you know, of how it's supposed to be. Most engineers usually design the pressure drop across a distributor nozzle 35 pounds.
That's the tubes and the nozzle. Yep.
Yeah.
That for like 404A or 448A, it'd be 35 would be what you shoot for.
Yeah.
410A is a little higher, but that's, you know, 45. And then anything that's like 134A type pressures is 25.
And I know it seems kind of, you know, weird me bringing this up, but what can potentially happen, even in refrigerated, you know, cases that you find in a gas station, supermarket, it doesn't matter. Sometimes what will happen is, because you'll have that excessive frosting on the distributors, that frost will actually grow. Once the frost grows, it might grow onto the suction line, which then will throw out your superheat. And because we're using all electronics nowadays to try to get that energy efficiency, it's getting, the controller essentially is getting bad information, so it's going to make bad decisions and affect the operation of the system.
So it's just so important to follow proper installation practices, lean on the manufacturer, find out their requirements, make sure your equipment's sized right, especially in the retrofit market. I mean, even in new installation too, but we got to make sure that we are sized right. Is there anything else that you think we need to cover, Jerry?
I think, you know, most wholesalers they're going to stock all AWF equipment. So
yes,
if you're going to replace just a condensing unit, make sure you double check the sizing of the expansion valve. There's probably 90% chance you're going to have to upsize it.
Yeah.
So take that into account. And yeah, just follow the instructions and use the tools we have. And there's a great YouTube video on how to use that 500 bolt-in we just mentioned. David Thomas, one of our product managers, put it together. So if you look up YouTube, go to our YouTube channel and look at AWF training. It's like a 7-minute video that walks you how to use that.
And I'll put a link to the YouTube channel in here, but it is SPORLAN video on YouTube. But I'll put a link in the show notes of this video. Brett from the Advanced Refrigeration Podcast. Find information about him at advancedrefrigerationpodcast.com. Yeah, we're good.
Yeah,
we're good. We're going to clean or end this. Jerry, thank you so very much.
Absolutely.
And,
thanks, man.
We will catch you guys on the next one.